Good morning, my dear students. In the previous class, we discussed about the dielectrics and polar molecules as well as the non-polar molecules. Today, we will talk about the capacitance of the conductor. As the name indicates, capacitance. Capacitance means it is the capacity of that conductor. We know that when a charge is given to the conductor, we suppose that there is one conductor, and if I add the charges to this conductor, then its potential increases. Its potential increases. Say that Q is the charge given to this conductor. When I add the charges to the conductor, its potential increases. Its potential increases. At what extent the potential increases? At what extent the potential increases? There is some limit. It has some capacity. So that can be written as, that is Q is equal to C into V, where C is the capacitance of that conductor. C is the capacitance of a conductor. Capacitance of a conductor. So Q is equal to C into V. Alright. C is the capacitance of that conductor. Well, C we may call also it is a constant for that conductor. We call C is a constant for that conductor, and we call them as what? Capacitance of that conductor. Therefore, we can write capacitance of the conductor C is equal to Q divided by V. C is equal to Q divided by V. Right? So, C is equal to Q divided by V. From this relation, we can define the capacitance of a conductor now. Right? So, Q is nothing but charge here, V is nothing but the potential. So, capacitance of the conductor is defined as it is the ratio of charge given to the conductor to raise its potential. Charge given to the conductor to raise its potential is called as capacitance of that conductor. Alright, I will write here capacitance of a conductor. Capacitance of a conductor is defined as it is the ratio of charge given to the conductor to rise its potential. It's a ratio of charge to the potential. So, I say that whenever the conductor is given some charges, it will increase its potential. So, it has certain constant, or that has a capacity to store that charge now. So, once the capacity is constant, say that there are two kinds of the shapes now here. There is one conductor of this shape, there is a conductor of another shape. I can say that I can store the charges here. I can store the charges Here also I can store the charges, but as for the geometry of this conductor, I can store more charges here than that of this here. Because of the shape and size, we can store the charges. That is why we say that capacitance of the conductor depends upon the shape and size of the conductor. It depends on, right here, it depends on first shape and size, shape, size and medium of the conductor. Suppose it is filled with some liquid, so its capacity is changes now. Its capacity changes. So based on the medium, size, shape, the capacitance of the conductor depends. Right? So capacity of the different conductor is different now. We know that. Right? So that is why you can say that capacitance of the conductor, it is the ratio of charge given to the conductor to raise its potential, and it depends upon the shape, size and medium. Right? So here from this equation we can that say that C is equal to Q by V. We can have the SI unit of capacitance of the conductor. Say that SI unit of capacitance is farad. SI unit of capacitance is farad. F-A-R-A-D, farad. It is the SI unit of the capacitance or capacitance of a conductor. Now, when I can say that it is 1 farad, if Q is equal to 1 coulomb and V is equal to 1 volt, then C is equal to 1 farad. If 1 coulomb of a charge given to the conductor rises its potential by 1 volt, then we can say that capacitance of the conductor is 1 farad. Like I am going to define the farad here. What is farad? How we can say that 1 farad? If 1 coulomb of a charge given to the conductor to raise its potential by 1 volt, then we can say that capacitance of that conductor is 1 farad. Right? So C is equal to Q by V is a very, very important expression. Using this expression, we can find the capacitance of that any conductor. Right? Say that here there are, you can say that here we can find the capacitance of the earth also. Say that to find the capacitance of the earth, first I will write here capacitance of the spherical conductor. Capacitance of the spherical conductor. To find the capacitance of spherical conductor, capacitance of a spherical conductor, okay, I will take one spherical conductor. Let R be the radius of that conductor. Now I will charge this conductor. Then we know that potential of this conductor, we can find the potential of conductor is V is equal to we know it is 1 by 4 pi epsilon naught q divided by r, or charge is given, that is q. Right, from the definition of capacitance, we have C is equal to Q divided by V. Now what I will do here, I will substitute the value of V here. We have the value of V, that is 1 by 4 pi epsilon naught Q divided by R. So what is the value of V? It is Q divided by 4 pi epsilon naught R. So this Q get cancelled. What remains here? C is equal to 4 pi epsilon naught R. This is the capacitance of the spherical conductor. This is the capacitance of the spherical conductor. Using this capacitance of the spherical conductor, we can find the capacity of the earth also. We can find the capacity of the earth only by substituting the radius of the earth r, that is 6.4 kilometer, 6.4 into 10 to the power 3 kilometer. If I substitute here the value of r and the constant, that is permittivity 8.854 into 10 to the power minus 12, after calculating we get the capacity of the earth, will approximately comes C is equal to 711 microfarad. 711 microfarad. 711 microfarad means, micro means it is 10 to the power minus 6. 10 to the power minus 6. So when I substitute the radius of the earth, the value of radius of the earth in this equation, and after substituting all the constant values here, I get the capacity of the earth, that is C is equal to 711 microfarad. Practically this micro looks very small here, but in practical actually 1 farad is a very large unit. It's a very large unit. When I substitute the large units, the magnitude of this value becomes very, very small. That is why we use all the capacitance in terms of what? Microfarad, picofarad and nanofarad. Right? So this is all about the capacitance of the conductor. Right? And in next class we will talk about the capacitors and its principles.